Hi everybody. This is part 3 of my general geometry A overview. In my last video I ended with number 18 and I'd like to go ahead and pick it up from that point and continue. So what we have to do in number 18 is find both the distance and the midpoint between these pair of points. Now I'm going to go ahead and begin with the midpoint actually and then end with the distance. To get the midpoint means that you have to get the average of your x values and the average of your y values. So setting it up that way is actually quite simple. So I'm going to say that the midpoint, just abbreviating there, midpoint is going to be the average of my two x's. So that means -1, which is this, plus 1, which is this, all divided by 2, and then the average of my y's. So that would be this one. So 3 plus 7, which is that one, divided by 2. Now, that would give me, as an answer, if I just do everything at once, this would be 0 divided by 2 would be 0, and then this would make 3 plus 7 would be 10. 10 divided by 2 would be 5. And my midpoint would be at 0, 5 for that one. Okay, now this is different from the distance. So the distance between 2 points does involve the use of a radical. And I'm going to switch colors here. So the distance between those 2 points does involve the use of a radical, and instead of getting the average, we're going to get the difference. So here we go. It's going to be the difference of our x's, which would be -1 minus 1, and then we square that, and this would be plus the difference of our y values, which would be 3 and 7. So 3 minus 7 squared. Now, one thing I get asked a lot by students is, does the order matter? In other words, could I put, for the y's, could I put 7 minus 3, and then for the x's, could I put 1 minus -1? And the answer is yes. The order doesn't actually matter, nor does it matter whether you put the x's together first or you put the y's together first in this line when you go this way. The reason it doesn't matter is because, number one, they're all under the same square root anyway, and you're going to combine by addition. You're going to combine those results anyway. But the other reason is because no matter what you get from these parentheses will be squared, and that means if you get a negative value, you're going to square it, it'll be positive. And if you had a positive value, well, when you square it, it's still going to be positive. So the order does not matter, and that flexibility makes this actually quite nice to work with. So getting back to this will be radical. This will be -2 squared, and this will be plus a -4 squared. So just be careful with the powering of a negative value, and so you get the signs right. So -2 squared is 4. -4 squared is plus 16, which would give us radical 20. Now, radical 20 can be simplified. So if I were to split this into 2 of its factors, what I would get is I would get a radical 4 and a radical 5. And actually, perhaps I should go more to the right so I have more space. So this would be radical 4 times radical 5. And because radical 4 is a perfect square, this would then come out as radical just 2, and then radical 5 is an irrational number. It's not coming out, so 2 radical 5 units would be our distance between our 2 ordered pairs over there. Okay, that's how you do number 18. All right, going ahead, moving on, number 19. So for this one, we have to find the other endpoint of a line segment with the given endpoint and midpoint. Now, this is very much like the midpoint we got between those 2 ordered pairs. However, the difference being that, unlike number 18, where both endpoints were given to you, this is an endpoint, that's another endpoint. In number 19, you're given one endpoint and then you're given the midpoint, and you're supposed to find the values of the other endpoint. Now, to help you understand this, it might be good to actually draw this out. So I'm going to draw this as a diagram, okay? So we have one endpoint, which is negative 2, 6. And then we have the midpoint, which is over here, which is negative 6, negative 5. Okay, but what we don't have is the value of the other endpoint. So I'm going to call this my mystery x and my mystery y. Okay, and this is what I need to figure out. So again, we have to apply the idea of the midpoint being the average of our x's and the average of our y's. So if I apply it in that way, I could say that the average of this value, and whatever that would be, would equal this negative 6 over here. So if I write it the way I say it, then it would look something like this. It would be negative 2 plus whatever value of x is my other endpoint, divided by 2 would be equal to negative 6, which is the value, the x value of my midpoint. Okay, this is my midpoint. And so if I solve this, this now becomes negative 2 by cross multiplication. So I multiply these two together. So it's going to be negative 2 plus x, which is my numerator, is equal to negative 12, the product of 2 and negative 6. Then adding 2 on both sides, I would get x is equal to negative 10. And just like that, I now know the value of my x for my other endpoint. So this is now negative 10. Okay, now to get the y, I do the same thing, except with the y's. So I will say that the value of my, and I'm going to erase this here, the value of my 6 added to whatever my mystery y is will give me my negative 5. So I'm going to set it up that way. 6 plus my mystery y divided by 2 is equal to negative 5, the y value of my midpoint. And like with the x's, if we cross multiply, this would be 6 plus y, which is the numerator, is equal to negative 10. And then subtracting 6 on both sides, we get negative 16. And that would be my y value. So now I know exactly where my endpoint is located. It's at negative 10, negative 16. All right. Over here, we have to get the value of x, and then we also need to get the value of PQ, the length of PQ. Now, this question is good because we have to apply sort of different principles here. First of all, we need to know what we're looking at. And what we're looking at is a triangle with some red markings here. And I just want to go ahead and walk you through what these mean. So these symbols indicate that this side and this side are congruent with each other, which can only mean one thing, that this point L right here must be a midpoint. Okay, it's the only way that that the two segments on either side would be congruent to each other is if this point L is a midpoint. And if we look at the opposite side, we have the same type of markings, and that indicates congruency here and here. And that means that point M also must be the midpoint of its side. So what we're looking at here is a midsegment. It's a midsegment of this triangle, PQR. And so what this does for us is it opens up some principles, which says that ML, that side I just erased, so this is exactly half of this. Now, I could write it as ML is exactly 1/2 of PR, which is the base of that triangle. But I could turn this around and I could say this, I could put this in perspective of PR, and I could say, well, if ML is half of PR, then PR must be twice or double of ML. In other words, it takes 2 ML midsegments to equal 1 PR base. So it depends how you want to set it up and what you're comfortable with, whether you're comfortable working with a fraction or you prefer a whole value. But either equation can help you solve this equation to figure out the value of x. So I'm going to go ahead and go with the whole value, the 2 ml equaling 1 PR. So the way you wrote it as a model is the way you set it up with the expressions. PR is x plus 24. So now we have x plus 24 is equal to 2 mLs, which is x plus 16. That's a value of 1 ml. And then we go ahead and solve this thing. So it's x plus 24, applying the distributed property. We get 2x plus 32. And then if I do two things at once, which would be if I move the x over there and the 32 over there, I can do two things at once and save some time and space. So I would get x on this side, and then subtracting 32 with the 24, I'm going to get a negative 8. And that would be the value of x. X is negative 8. So that takes care of part A. Part B is, what is the value of PQ? Now, PQ is this entire length over there, the entire thing. And in order to figure out what that is, I need to first substitute my value of negative 8. I need to plug that in to this space here, because this represents the length of L all the way to Q. And once I know that, I can simply double it and figure out the length from P all the way down to Q. And the reason I can do that, once again, is because point L is a midpoint. And so LQ and PL are congruent. Therefore, if I simply double the value of LQ, I can get the entire length of PQ. That's my plan, my master plan. So here I go. LQ is equal to negative 2 times negative 8 minus 5. And this would be 16 minus 5, which would be 11. Now, I'm going to use that, like I said, to get the value of PQ. So I'm going to say PQ is equal to 2 LQs. And that would be 2 times 11, and that would be 22. And with that, we are done with this question. So the trick to this really is understanding what a midsegment is and how it relates to the base of a triangle and what it does to the sides of a triangle. And it all involves the midpoint and what that does. So I'm just about out of time, unfortunately, but I will be making another video. And so please be sure to look out for that. And as always, thanks for watching. Bye-bye.